Greetings. Welcome to our 29th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
Hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we are going to focus on our May 6th, 2021 webinar titled Deep Water Leak Location Surveys, Highly Sensitive and Very Effective. I'd like to quickly reintroduce our speaker, Mr. Matt Chemnitz, who is president of Leak Location Services, Inc. in San Antonio, Texas. LLSI has surveyed over 500 million square feet of geomembrane at almost 4,000 project sites all over the world. This vast experience of performing leak location surveys at sites ranging in size from 1 acre to over 200 acres has provided Matt with valuable training to fully understand the aspects of leak location survey methods. Today, Matt, I want to go through some of the questions we were unable to cover at the end of your webinar and the questions we received in the post-webinar survey. Okay, Matt, question number one. Does the accumulation of sludge on the bottom of a lined pond hinder the leak location survey, and how much sludge is too much?
So when you have a lot of sludge on the bottom of the pond, the main thing it does is it does not allow the leak location equipment to follow the liner and actually be close to it. It has to be off the liner, whatever thickness that sludge is. So the sensitivity is reduced because you're further away from the liner. I would say you want to keep no more than about 3 feet or a meter of sludge on the liner, just to keep that sensitivity. Otherwise, you could tow the equipment closer spacings to kind of make up for that sensitivity. But also with too much sludge, that sensor can try to dig into that sludge and really cause issues. So ideally, less than 3 feet is a good go-to.
Okay. Next question. What if the sensor is while it's being dragged, hits a crease or wrinkle in the geomembrane? Can it impede or do damage to the geomembrane when the survey equipment is being dragged and it hits this wrinkle?
There won't be any damage done by the equipment when it hits a wrinkle. The way the equipment is designed is it has rounded, smooth edges. So it allows it to hit wrinkles and then slide right over that wrinkle and pull over. There's no sharp edges. There's nothing that would cause any kind of damage or even a scratch on the liner.
Great. Third question. How would a GCL under the geomembrane affect leak location testing? Would copper, or like a copper wire, need to be inserted between the GCL and the geomembrane?
The copper wouldn't have to be inserted, but it's not a bad idea, especially if you're testing the site with GCL between, and it's been a long time since that GCL has been placed. You're worried about it becoming dry. You can go ahead and put in a liner during installation, a copper wire during the installation process, because if you do have a dry spot in that GCL, that copper wire will kind of serve as a go-between all those dry spots and allow it to kind of connect up and give you a more sensitive test. But if it's newly installed GCL and you're testing it right away, there's not a need for the copper wire.
Okay, Matt, next question. What are the different methods for designing electrical conductivity into single and double composite liner systems without using a conductive geomembrane?
Okay. For a single line system, I can't think of a reason to use any kind of conductive geotextile or conductive liner. It's just not necessary. Even when it's placed over geocomposite, there's enough moisture to detect a leak. But for double line systems, something has to be between those two layers, the two geomembranes. It needs to be conductive. Many times this interstitial space is flooded with water, and that allows the floor to be tested and partially up the slope. But if the entire slope needs to be tested, then a GCL or a conductive geotextile could be used between those.
Great. Next question. You mentioned placing copper conductive wire between geomembranes on a double liner system. What are some of the other ways that a conductive leak measuring system can be installed between two geomembranes in a double liner system? In other words, is there anything else besides a copper wire? You mentioned a GCL just a minute ago.
Other than a copper wire placed between so you can test in the future, there is another system that's out there. It's called something different depending on who is doing the leak location work. But you can install a permanently installed system that essentially is a bunch of electrodes under the liner put in before the site is built, and it allows you to test that site over and over and over with downloaded information. No matter what's on top or how thick the sludge is, it does away with that being an issue, and you can test it. It's a little more costly, a little more involved, but if this is something that's important, that can be installed.
Okay. Next question. Are there any precautions required to prevent pulling the rope up with the equipment as it comes out of the liquid and gets on the ground surface?
I really like this question. This question shows that whoever's asking it realizes that that rope will have moisture in it and could cause a grounding situation. This is not something that happens to us, but, and the reason is when the probe that is actually detecting the leaks is pretty far away from wherever this rope is, except for when it's at the very, very end. So most of the times it's far enough away to where you don't hear it. It's just picking up the current densities in that location. However, if you have a pond that's very full of water with maybe a foot of freeboard and that rope is wet and the sensor's right there, yes, it will detect it. So in order to keep this from happening, you can just put like a scrap piece of liner where you're pulling it and keep it off the grass, or stay on the side slope, and that keeps that rope from grounding you out. But that's a great question.
Yeah. Let's see. Next question. Have you conducted any electrical leak location survey on mining projects like leach pads, tailing dams, etc.? If so, have you noticed any significant difference with hazardous waste or domestic waste landfills? Seems to mix
So
up.
We've tested these mining projects many times, leach pads, tailings dams, etc. There's not really a difference in the type of leak that we're finding regarding these two types. But many hazardous waste sites do require testing on a recurring basis. The mine sites don't tend to have that repeated testing. They usually have testing when there's an issue.
Right. Would it be possible to use this leak location technique for a geomembrane protected by a 0.6 meter thick or 2 foot thick silt layer with some grass in the surface of it?
So if the silt and the grass are underwater, you can test it. You would just have to tow the probe or float it above that grass and silty area. It would reduce the sensitivity slightly, but you could still do it that way. If the grass is coming out of the water, then you have to, it would get tangled up in those grasses and weeds, and you wouldn't be able to physically pull it across. So in this case, it would be best to clean it out, or at least remove a lot of that stuff on the top of the surface to make it more testable.
Thanks, Matt. Okay, next question. Do we always need conductive materials between two geomembranes to facilitate a leak location survey?
Yes, there has to be something conductive between the two layers at all times to test it. It could be a conductive liner the bottom side would act as that material between the two. Usually it's water between the two or a conductive geotextile between the two, but there always has to be something between the two to detect a leak. The only possible way that you wouldn't is if you are going to, I guess, hope for the best and test through both layers. So you're going to put an electrode above the 2 layers, and an electrode in earth ground. And in that sense, you're going to have to find the leak in the primary and a leak in the secondary close to the same location in order to pick it up.
Yep. Okay, Matt, last question. Without some sort of conductive material between the 2 geomembranes, you will not find a leak in the primary geomembrane. If a leak is large enough and liquid goes through it and travels all the way back to the ground electrode, you will find it. Any small leaks that do not make a connection back to the ground will not be detectable. You could also have a leak that penetrates both layers and connects to the earth, as well as have enough moisture to make it through all the layers in between. So this sort of dovetails to the last question about two geomembranes.
Right. It's basically explaining that if a leak is in the primary, it'll have to be in the secondary too to find it. If there's nothing connected between the 2, any leak path will have to be a complete circuit back to the front or back to the equipment. So this is important. Why you should have either a fabric that's continuous, a conductive liner, or water that's in between the layers, put in there for the specific reason to make sure that path is a complete circuit to find the leak.
Right. Okay, Matt, that's all the questions we have. Thanks for joining us again and answering these last few questions that came in. If you have any additional questions or like additional information about leak location surveys, please contact Matt at mattk@llsi.com, or you can email me at fabricatedgeomembrane@gmail.com. So Matt, thanks again for joining us from San Antonio and giving an excellent webinar on leak location surveys.
Thank you both so much, and thanks everybody.
Thanks, Matt.
See ya.
Bye.